Good evening, year 12s. Welcome back to this week's lesson. Today we're going to look at data transformations, pretty much looking at all the transformations we have, square and log transformation as well as reciprocal. First, look at the square transformation. Let's say I have a set of data, or rather they are related such a way that it's in a square formation. Now in this case, you notice it's sort of like y equal x square form. Now what I'm going to do is I am going to spread the x values across. You see the y height gets larger and larger as we go through. Therefore, we apply so-called x square transformation. What would that do? That will square the x value. If I had a line there, it is square the x value and move out or push these points to a point on this line, or rather get closer to that line, so that this particular now new set of axes is now y against x squared. Therefore, if I were to find the gradient here, let's say m is 3, then I can write down, okay, y is equal to 3x squared, simply because it is against x squared. Does that make sense? Are you with me, everyone? Did you nod or give me thumbs up?
Yeah.
And that's when you have y is getting larger against x. However, similar manner, if you had a situation where you had y is getting smaller, like this, then we would go with square transformations for y as y squared. So I'm going to square the y values. Then the height becomes larger and larger. Hence, if I had a gradient for this one, let's say m is 2, my functional form is y squared is equal to 2 times x, because that is now new system is the y square against x. This one is y against x squared, the other one is y squared against x. Could I get you to copy this? All what you got to do is square the values given if you've been asked to do so. Then, for example, if I had this as, let's say, time, and this as the distance, then my equation of the form is distance is equal to 3 times, not just time, it's a square value of the time. And then obviously I might have another component, let's say for just an intercept, y-intercept. It could be distance or height or different variable. Copy that, please. Now, in this case, for example, in here we can think of, we are going to fertilize something, we get a yield. Y is my yield. And now yield square is equal to 2 times, let's say there's another, 1. And this is the, whatever the square meters area. So 2 times the area plus 1 is the yield. The yield could be in different unit. That is how many fruit you're going to get, something like that. Does that make sense? So likewise, you need to replace your explanatory variable and the dependent variable in terms of what is being given. All right, on that note, let's do a bit of a work. Or rather, let's go and now work on the other transformation. The other one is the log transformation. We'll work on that too. So the log transformation. The log transformation is when the values are big. I should say the log. Then you make it smaller. So you apply the log values so that it gets squashed nicely. What does that mean? If you have a scatter plot where they are scattered that way, then you can actually push them in nicely into the smaller values so that they nicely align using log. So this is log 10x. That is a log transformation. On the other hand, if you had this way, now you can push these down so that they align nicely on a line using log transformation on y. So if that is the case, whenever you use, let's say, different variables, then you gotta look for the given log transformation. In this particular scenario, now this is being converted as log x, y against log x. For example, we can think of lifespan and the GDP. So x is GDP. Then if I were to get an equation, for example, I can think of lifespan. Here the lifespan. Then I can write down, all right, lifespan is equal to, let's say, 56.7 as my so-called the intercept is starting. That means with basically without considering any GDP. Now we can work on, let's say, 6.23 times a log value of GDP. Remember, it's not just X, it's a log value of X. Hence, you gotta write as a log GDP in your equation. Transfer that. Are you with me? So that's the transformation you're gonna look at in log sense. Right, I'll get you to copy that as well, please. The last transformation that you would learn in this subject is the reciprocal transformation, as I mentioned before. Okay. For this case, we are going to look at either 1 on x or 1 on y. So the 1 on x, we got to look at depending on how the data is going to be scattered. Again, if the x and a y would have a similar to, let's make it a little bigger. So the 1 on x, like that. So we could basically work through if these values are close to 1, say you have values between 1 and 0 as well as some bigger than 1. Then what we expect is these values to be, when you take the reciprocal, these values would go below 1 and these values would go above 1. Does that make sense? Because 1 divided by smaller values becomes larger values. Therefore, your line becomes more sort of like that way. Does that make sense? That's around 1. So you got to remember that. The log values is when the values are very large in this sense, this particular behavior, similar setup, similar graph. However, if it is between 0 and 1 and above 1, then you use log 1 on x, which is reciprocal. Similar, you can think of for x and y the same. Well, for the 1 on y transformation, same here. If you think of, okay, I have x and a y and bigger values and then get smaller. However, the values are across 1 now. That means the bigger values become smaller, the larger values become, sorry, smaller values become larger. Hence, you get a similar line that way. Okay, that way. So that is 1 on y. So make sure that you do apply appropriately. You will be asked in a question to do so. However, it is quite noticeable, it's around 1 for reciprocal and log is for larger values. Are you with me? So
Yeah.
you can have larger values bigger than 1, but there are significant number of values below 1. That's what it is.
If it's over one, how do you know? Like if it's over one?
Over 1,
Yeah.
over 1 would be log because it's become larger and larger. You want to make it small. Right?
Yeah. Okay.
If it is between 0 and 1 as well as over 1, that means around 1,
Yeah.
below and above, then that's reciprocal.
Okay.
Does that
Yeah.
make sense? The
Yeah.
difference between log is larger values. Could be
Yeah.
2, 5, then 10,000, 2,500, blah, blah, blah. Bigger numbers, you want to make them smaller so that similar scale, that's a log.
Yeah.
It's a similar sort of a plot here for the log. Exactly the same plot as this one. Same
Yeah.
as log. But the log values are larger values. If your values are between 0 and 1, the log function is normally like this. It's there. You can't
Yeah.
even see in this graph. This graph has been scaled up, zoomed
Yeah.
in, so that you can see the 0 to 1 as a bigger value.
Yeah.
If you
Okay.
get log, the 0, 1 here. So I'm talking about whatever I drawn here, there. Can you see it?
Yeah. Yeah.
And your dots for the log would be something like this. They are nowhere near in this graph. Does that make sense?
Yeah.
Good question. Copy that, please.
Yeah, I got that.
Okay, now what we're going to look at is circle of transformations. Now in this one, what we are looking at is understanding what we're going to take depending on what type of a transformation to be applied given the data. So if the data looks like on a circle on the far corner, top left, that is either log x, that means you're pushing your values here, so you make it smaller that way so that you can make it straight line, or you take the reciprocal as you've seen before if the values are between 1 and 0 and above 1, right? And then also you can say y square, that means you're going to start pushing these up so that they nicely align. Are you with me? So we're going to put all of what we learned now into a circle. So the possible transformations for that type of a shape of scatter plot would be x square and y square. You keep pushing either y heights, or you can get all these values, x values, so that they align nicely on a straight line. Are you with me, everyone? Good. And then here, if that is the case, that's like that, it would be log y 1 on y and x square. And similar manner, if it is on the other part, that means going down like a hyperbolic form, that is 1 on y or 1 on x, either log or log y. The all four applies here on the far left corner on the bottom. I'll get you to copy this. Once you copy it, we can work on the set work. Basically, that is pretty much everything for the topic. So well done. We covered our topic today pretty fast, which is great. So on that note, let's get on with some work now once you copy this.